couple of comments on Round Tower. We are a solution provider based out of Cincinnati, Ohio, serving the eastern U.S., 10 years old. Have had great success and growth primarily because we approach things from a deep technical capability and expertise fashion. We focus in 5 areas: data center infrastructure, orchestration, automation, and cloud, DevOps, collaboration and mobility, and data analytics, which is why we're here. In that space, we focus in a couple of different areas: data integration, data preparation, and modeling in a couple of different ways, one of which would be in the area that Dave is going to talk about next. Next speaker is an industry leader for retail, manufacturing, and Internet of Things for Cloudera, Dave Shuman.
Step back and slide. Slide. So presentation type talk here is, stop that. I'll move very carefully here. IoT Analytics, is it going to be hype or truly transformative? And the answer is hype. Thank you very much. Have a good afternoon. So as Steve said, I lead Cloudera's industry practice around IoT manufacturing and retail, which as you start to sort of back that out into your world, that means I get to talk to every single one of our customers that are out there in some manner, shape, or form, because either they sell things, they make things, or they have sensors that are operating on things. And this is kind of an interesting space as we get into the Internet of Things and how companies are using and leveraging this. And I wanted to talk a little bit about where we see this going, and so what the realm is around IoT. And it really starts to break down across 3 key areas that this is transforming over time within organizations. And to cheat ahead here, we're kind of in stage 1 right now, which is we're really trying to figure out how do we get all of these different sensors that are sitting out there connected so that we can use them. I don't know if you heard the presentation earlier this afternoon from the city of Pittsburgh talking about their initiatives around smart city. And they went out there and they said, well, we are going to connect up these 5 buildings and start to understand some seminal things about what's going on with energy usage and their telecommunications. And they got into the first problem, which is how do you get these things connected? And so really where we see the sort of the energy around the industry right now is focusing on this area around connecting things together. But we're starting to get some glimpses ahead into what's going to happen once the data gets all connected together. And that is integrating this into the actual device itself. How do I make the device contextually aware of its surroundings? So we get these things now. We start to see this in our GPS, whereas we're navigating across, it's starting to know things like weather and traffic, road conditions, other things that are going on like events that are informing that out at the edge. But the goal of really where we want to get is autonomous. And I thought that was also interesting in the city of Pittsburgh presentation is they showed the control room that was sitting in there that had hundreds of screens and monitors up there with 9 individuals that were sitting there watching them. And that's not really where we want to go with autonomous. What we really want to do is get these things programmatically approaching these and telling us what they did, not presenting us with interfaces that allow us to see what's going on. But that's sort of the evolution that we're going through along the way. And this would be a non-connected device, just in case you wanted to know as I point this at the back. All right, would you mind advancing the slide? No worries. That would be, okay. I'd like to tell you about our sponsors today. So as you get along this journey around connected devices, this is also a really good example here of how when you're working with sensor data, sometimes you have to deal with anomalous signals that are happening along the way. I'll talk about this in sort of the hierarchy that we get around this. Back into the characteristics of data. So the core that you see here, and most of what we're dealing with today, is a very granular view of sensor readings and objects that are going on within their environment. So this room in here has a number of sensors that are in here that are collecting information right now. the ability for that then to be coalesced becomes part of a time series orientation on data. And we really have two perspectives that we want to work on with IoT-oriented data. One is we want to see the data in its nature of how the data is streaming through in time. And we also want to see that point in correlation with others associated around time. So that's going to be the longitudinal view of that particular sensor over time. The second one that we're going to want to do is we're going to look at that and we're going to say, to be able to rule on this in the immediacy of the moment, we're going to want a set of characteristics that say, right now, this sensor reading is X. And then I can look at that later to say where that sits within its time series. This is going to end up being a problem in how we need to work with data that's going to stress our traditional data management methodologies around that. The other thing that's really interesting about this is we're seeing a very rapidly evolving space here where schema is evolving. So the sensor reads that we have today and the way that data is coming at us today is continually changing. And we have to be able to deal with that mutable schema, as it were, because there's 31 different standards organizations around schema today, how data is being transmitted, what the format's going to be in data. And so for us to work with IoT-oriented data, we have to have a giant catcher's mitt that can really catch anything that's being thrown at us. A friend of mine who is the enterprise architect at Intel, named Mati Fanya, wrote a piece up there. He called it Mati's Hierarchy of Needs. Wow. So one more time on this mic and we'll switch over to something else. As we see this here, you really start to move this through from as data is being created, we need to have something at the edge that is scalable, shared nothing, to be able to collect that data at whatever level that's coming in. And if you think of that as sort of our first stage of problems that we're trying to conquer today within this environment, we're looking at how do we capture data on its ingestion point. The next thing that we need to do as an organization is understand that data. And because we're humans, we want to see some nature of visualization that we can operate on that data. We want to be able to look at that over time. We want to be able to understand the characteristics data that we've never had the opportunity to see before. With that, we're going to start to do things like creating rules off of this. Let the other one come down. Oh yeah, this is much better. And so within those rules, we start to say, how do we create things that are going to look at these various different thresholds? When the pressure exceeds X, I want to know about that. When the temperature exceeds Y, I want to know about that. When the capacity of individual heat signatures in a room exceeds 69, call the fire marshal. These are the kinds of things that we're going to start to see in the data, and it allows us to create immediate value off of that data. Before we move into this next piece, we need to understand the characteristics, and as this sensor was just indicating me a little bit ago, we need to understand the anomalies in the data to be able to create programmatic approaches to that. We will then start to put the more shiny objects into this. We're going to look at techniques like machine learning to get value out of this data to create models that can be used in a real-time, responsive, autonomous fashion, and that's really getting over here to the high-end sets of value on it, which is creating applications that are operating on top of that data. But you have to get through these stages of this, so as you understand the nature and you're going to turn over the controls into an autonomous process within the organization as well, you're building trust. And so not only do we have to get the models right about this, but we have to convince the people that hold the control today that they're going to hand these controls over to autonomous processes. We're able to prove out their value to the organization and their ability to generate accurate results. And in this abstract, we've talked a little about this being in the nature of architecture. When we tend to think about data problems, we have been trained to think about that in traditional BI architectures. And that means this concept of schema on write. I often get the question when they come in about talking about sensor data, what's the table structure going to look like to be able to hold that? We get these questions that persist to say, what are the use cases that you're going to operate on with the data? That is a very traditional BI framework of thinking about that. And we're starting to get into two different axes on this. One is we get into more and different data, and then the second is we look at architectures that are able to operate on data in motion. So we consider this to be fast data architectures. In the realm of traditional BI, if this thing had a bumper sticker, it would read, capture only what's needed, nothing more. You must justify the nature of data before you bring it into this contraption, because there's a heck of a lot of work that we have to go through in order to prepare data for you to be able to use it. And so in this, the business predetermines the nature of the questions they're going to ask about the data. IT structures that data to be able to answer those questions, and then turns over to the business and says, all right, what do you do next with that? And that's sort of the traditional schema on write realm that we have been trained with over the last 30 years. As we get into this concept around big data, we don't necessarily know what we're going to do with the data before we bring it in. And so I love Dr. Peel's example this morning where she showed the kitchen, where you have this great preparatory environment that chefs can come in and do their art. And so this is an environment where you can bring and ingest the data because you believe that it will have value to the organization. This is data that in many cases is ephemeral. It's flowing through your organization right now, and if you don't capture it, it's gone. You'll never be able to go back to this point in time and start to collect, establish what is a baseline of normal operations. And with this now, the business is exploring the data, building out the use cases, and building applications that tie off of that to really get into this third framework, which is how then do I operate on the data in motion? As we see these conditions occur within our business, we wish to take these specific sets of actions, and we turn over the controls into these nature of autonomous processes. Notice in the world, in there we had the words near real time, because as we start to think about some of these architectures out here that are working today, things like fraud detection engines, next best offer, recommendation engines that are using this kind of a fast data profile tend to work in the low milliseconds of latency. When we start thinking about true autonomous processes, and this is you get into the autonomous vehicles, 10 milliseconds is too late. And so we're really looking at how do you continue to compress those kinds of envelopes so that you're informing the models to the edge using the full corpus of data that's available to you. And with this, you get into an architecture where you're starting to decouple how data is being generated and data is being consumed. And even in this way, we start to think about decoupling how we ingest data and from its source systems to what does this look like in an optimized application mart environment. And the architecture that comes into this, and you start to get this in these big data environments, is you capture data raw in its native fidelity. We often think about, we have these evolving schemas that are going out there. We have these evolving standards organizations. That ends up being a barrier when you think about pushing this into a very specific data store. In these kind of big data environments like Hadoop, you ingest the data in its native form. You curate that as an ingestion into the platform, and then you start to build the uses off of that. You go through these points where you start keying the data. You say this entity is equal to location. This is equal to an asset. I'm starting to tie and build structures around that, and I'm starting to build models that explore the use of that. And as we start to get to the end, as we find things that have efficacy, I'm able to, to improve my HVAC usage in the building by using these sorts of sensors. Then I'm going to start looking all the way down here at the end about how do I optimize that for the nature of activity that's going to occur on that. But we're very far away from creating what looks to be much more like schema on the right end, where we have data models that are operating for this, versus where we're at the beginning of the stage, which is how do I ingest these raw signals to be able to use these. We talk about this in the framework of big data in being agile. And so one of the things about being agile in here is, if you think of these in the sort of the realms of what do we know at the beginning of this process, it's really a fairly small amount. We have some hypotheses that we think about how we're going to use this data. And in fact, because we're smart people, we actually already have a body of knowledge that we want to achieve. We know what we don't know. We have this all sitting out there. We're thinking in our brains, like, if I can see the data and I can start to explore it and model it, I'll know this about how these different sensors are working within the environment or how those things interrelate. But there is a whole realm of stuff that you start to get into this as you explore the data and you look at how you can fuse these different data sources together, which is this realm of what you don't know. And so we don't even know what we don't know about this. And that's where you get back into that ingestion capability where you're separating the consumption of data from the generation of data. Don Knuth has a great quote, and I think, yes. So this is the Art of Computer Programming, both the book and the series. And I love this concept on this because as programmers and as IT professionals, we tend to think about how do we optimize these processes. How do we model this to third normal form so we're not double storing data in some manner, shape, or form on this? And we're ahead of the curve here. You don't know what you don't know. Or as Don says, premature optimization is the root of all evil. So get into this. This is where you say, start, explore, iterate through these processes as you're working with this in this data environment. There is one thing that I would be remiss out here as a vendor of some nature where I didn't talk about things that we were doing within the open source community and what Cloudera is doing in here. You start to hear about these things in here with Hadoop, which is the Hadoop Distributed File System, HDFS. Really good for the types of data where you're bringing in lots and lots of time series-oriented data. Many of these types of use cases have often needed a key value store as well, where you have some place where you're storing data where you can very quickly go look it up and retrieve the value for it. The number of people in this room is 72. The temperature is 80. Those kinds of facts, you don't want to have to read all of the data over all of time to get to the answer of what was the last reading. You need to store that someplace where it's easy to operate on that. And again, in the realm of open source on this has involved a NoSQL technology called HBase. But you're tending to create a fairly complex architecture for doing these things like real-time predictive maintenance or predictive analytics on the data, where you're storing current values, means, and other statistical derivations off that, and you're able to look at the longitudinal view, that full fidelity of the time series of data. And so one of the areas that we've just brought to the open source, it's now an Apache top-level project, it's called Kudu, which is a storage framework that has the performance characteristics that you read about, where you're able to bring in these large volumes of data, and specifically these things like time series analytics. But it also has the characteristics that a key value store brings, the ability to look up and grab and extract a singular value, or, really exciting, to be able to update a singular value. So now you've moved away from the sort of write once, read many, to a mutable data store where I can update current values that are within there. And there's some really neat use cases that tie into the value around that. So we're looking at this now with diverse and evolving data streams, our need to be able to ingest and process anything. And as we start to think about this, we in the world have said data has these characteristics. We have quote-unquote structured data, unstructured data, semi-structured data. Those terms we've really introduced because the systems that we had historically found anything other than structured difficult. So we started to say, well, these thresholds are going to have to be different if you want to bring in unstructured data like video or audio, or if I want to bring in semi-structured data like email and text results that are out of that. But the other thing that's happening on this is we have multiple frameworks that we want to use to apply data. I may bring data in a specific way and then start to work through it in a scripting language like Spark to be able to create a data model off of that. I'll use search technology to be able to explore and do fuzzy matching. And then I want to sort of lever machine learning on top of the data. So we now are bringing multiple frameworks to operate on data to be able to get the value out for these kinds of IoT-driven use cases. I wanted to bring one example up, and specifically, this is an interesting company, because as you think about people that manufacture large vehicles and engines and things like that, those tend to be, old, stodgy manufacturing processes. Navistar is reorienting their entire business around sensor-driven use cases. And instead of selling trucks, they're looking at selling the ability for you to have uptime. This is a product as a service offering on top of vehicles using these sensor-driven networks. And the ability here now is to look at things like predictive maintenance, but for you as an end consumer to be buying that kind of an uptime service based on analytics. So with that, I would say if Navistar is able to do this in this particular environment, it is transformative. That's it. Questions? Cool. All right, thank you.